Now, very closely related to those sequences that we just talked about are these things called, sorry, very close related to the summation that we just talked about is this thing called series. So if you were to take a summation, extend the upper bound to infinity, literally add an infinite number of terms, we're going to call that a series. Now, a series follows all the rules of sequence and can be compiled like a sum. So it's following the pattern of a sequence like we've been doing, and then we're adding them up. Now, consider the infinite sequence, a sub 1, a sub 2, a sub 3, etc., 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 and you'll see the dots keep going forever. Then the sum of the first n terms of that sequence is called a finite series. So it's like a partial sum. We're not adding up an infinite number of terms, we're just adding up a finite number of terms. So that'd be like taking the first term, plus the second term, plus the third term, plus, 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 until you get to the nth term. And we would use this notation. So the sum from I equals 1 to n of a sub I. So starting off by plugging in 1, so we get a sub 1, and then a sub 2, and stopping once we get to n. Now it gets cool, well, not that it's not already cool, but it gets kind of crazy, because we can also do an infinite series where we're literally adding up an infinite number of terms. This is something we're going to hammer home once we talk more about geometric series and sequences, but we're going to start off with one today. So the notation we would use, it really just looks like this. It looks like the exact same thing we've been talking about, but now our upper limit is an infinity. So you're doing your first term, plus your second term, plus your third term, plus your fourth, plus your fifth, plus your ith, plus your whatever, all the way up to infinity and beyond. So we're going up to infinity. Now looking at this example here, we got for the series from I equals 1 to infinity of 3 over 10 to the I, we're asked to find the following. We're going to start off by just doing the third partial sum. So that means we're really just doing temporarily from I equals 1 to 3 of 3 over 10I, or 10 to the I, my apologies. So we're essentially taking the first three terms, a sub 1, a sub 2, and a sub 3, and we're going to find the three of them and we're going to add them together. So let's find them. So we got 3 over 10 to the first. Well, that's just 3 over 10, which if you convert that to a decimal is 0.3. The next one, 3 over 10 squared. Well, that's 3 over 100, which is 0.03. Sorry, I don't know if you guys heard that, but my Amazon Echo just responded because I'm not going to say it, but she must have thought that I said the trigger word there. And she responded. I don't even know what she said. Anyways, 3 over 10 to the third for the third term gives us 3 over 1,000, which is 0.003. So if we were to add these all up, we got 0.3 plus 0.03 plus 0.003 gives us 0.333. And I bet if you kept that pattern going, if I added a fourth term, there'd be another 3. If I added a fifth term, there'd be another 3. In other words, if I were to do this pattern, say, not from I, forever, to infinity, we would end up with 3 over 10 to the I, and we'd keep on plugging those in. We'd add the fourth term, we'd add the fifth term, we'd add the sixth term, and it would just be 0.3 forever and ever and ever and ever and ever and ever and ever, which is the same as 1/3. So in this case, we'd add up literally an infinite number of terms. We'd be able to get a finite answer of 1/3.